Hello, everyone, and thank you for attending today's webinar, Integrating SD-WAN with Provider VPN for Optimal Performance over Hybrid Networks, sponsored by Huawei. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box, submit your questions to our speakers. All questions will be saved, so if we don't get to answer you today, we may follow up via email. At the bottom of the audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. Finally, an on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to Senior Analyst at Heavy Reading, Roz Roseborough. Roz?
Great. Thanks, Hannah. And thanks, everybody, for joining today. Like she said, my name is Roz Roseborough, and I'm a Principal Analyst at Heavy Reading, covering cloud infrastructure and management, and I'll be the moderator for the call today. I'm joined today by Linda Dunbar, Technical Director of Advanced Technology for Fixed Networks at Huawei. During Linda's presentation, we'll pause occasionally to do a few poll questions. We'll have time at the end to take your questions, but please do submit them as we go along. And now I will hand the call over to Linda.
Okay. Thanks, Rob, for the introduction. So let's get it started. Okay, so first we start with the challenges facing enterprises today. So everybody, many people is aware of our digital economy, and many enterprises today is facing challenges to do the digital transformation. They have many challenges and they have many issues. And first of all, digital transformation, the digital economy has a large volume of data. And those data need to be portable, need to be closer to their client, and need to be comply to the regulatory rules. And certain data can be stored in certain places. And the abundant availability of cloud data center enable this digital, basically bring an enabler to the digital economy, be able to allow enterprises to store data wherever they want, where they're closer to their clients. So in the past studies, we have shown that 85% of services or data is going to be integrated to the cloud. And of course, there are some kind of new type of economy like Netflix and Airbnb. Those kind of companies, they start is homegrown to from the cloud. They don't have the infrastructure. They basically depend on the cloud primarily. But most of the enterprises, they have their on-prem data centers. They have the critical data. They don't feel comfortable to be pushed to the cloud. So it is very, very important to be able to provide a way to securely interconnect the data in the cloud, the application in the cloud with their on-prem data center or with the branch offices. And of course, all those cloud is not just a single type of cloud. There will be public cloud as AWS and Azure. There are many other types of cloud data centers, on-prem data centers, and also like specific special purpose data centers. Be able to interconnect them becomes very, very important for enterprises. And also, this kind of new challenges and new requirement, new need for services bring new revenue-generating opportunities for service providers, which can be traditional network service providers or can be new type of service providers. Let's look at on this page. I personally go to Open Network User Group, in short, ONOG. ONOG is an organization formed by IT executives, and their goal is to for IT executives across the industry to share their best practices and especially challenges they face during this digital economy, and how to transform their IT infrastructure to support the digital economy. So they have meetings twice a year, and I personally chair their software-defined security service working group. And during their annual meeting, the user community will vote for their highly desired use cases. They basically put the dots on those use cases. One of the use cases being highly desired by those enterprise community is Cloud Interconnect, a broker, because different cloud operators offer different kind of services. For example, on the right hand, we see this AWS provided cloud services. AWS has lots of open information on the internet. You can find those services and how to use them. But there are many other cloud providers. They have slightly different. And so for many enterprises, they will need be able to, you use different cloud services, and then you need to be able to exchange your routes, you exchange your IP addresses, and exchange your policy, especially policy among each other, on top of the interconnectivity of all those different cloud services. And so that become highly desired by those enterprises. And actually, on top of that, I highly encourage people keep a look on this ONUG. They have developed quite a few reference architecture requirements, and they will be useful for any service providers who are aiming to provide B2B services. They'll be a good place to look at their requirements. So for ONUG, ONOG, it was founded back in 2012, and then 2013, it came up with SD-WAN, software-defined wide area network. So this being 5 years, and the industry has quite a buzz on the SD-WAN. Here, I just want to peel the onion to look inside SD-WAN and what kind of SD-WAN there are, and what kind of services there are. Is it actually a challenge to today's incumbent network service provider, or is actually the complement to the services they already offer and enable them to provide more value-added services to their existing customers, or being able to give them a tool to reach out to new customers? So when ONUG first created SD-WAN, it was pretty simple and naive in a way that, hey, between two branch offices, I may have internet, I may have my lease line, I may have my L3 VPN or L2 VPN, and today we all separated them, and it will be nice and economical to be able to aggregate all those bandwidth available provided by different service providers. So that was the initial idea on SD-WAN. Here we call it single-tier SD-WAN. Basically, it's like enterprises can do it themselves and buy two small boxes, put into their branch office, and voila, you can basically aggregate maybe 1 or 2 or 3, even 4 bandwidths between those locations. So on the paper, looks really good, and initially, a few years ago, SD-WAN was positioned as a lower cost alternative to the expensive VPN lease line. But as time goes on, people start to experiment with deployment, and they find out actually there are quite a few issues. It's almost like the old days frame relay. Before MPLS came into picture, frame relay was the dominant network technology. But the problem with frame relay is the multi-point to multi-point mesh interconnection that require all the CPEs to know all their destinations, be able to maintain a full routing table on where their application is going to. So it becomes really hard to manage. So that's how MPLS come into the place. MPLS come to the place with a good story of your CPE never need to manage your route table anymore. you just directly attach to a provider edge. And everything you want to forward to, you just forward to the provider edge device. So the single-tier SD-WAN has the similar problem as frame relay, the complexity of managing mesh interconnection. So then we come to this second model. We call it hierarchical SD-WAN. It kind of inherits the idea of MPLS provider network, except that the provider, the service provider, can be the over-the-top. They can be the one who doesn't even own any facilities and infrastructures. They can strategically put their devices like SD-WAN aggregator devices in certain strategic locations and allow the CPE to directly connect to those POP locations. And in the middle, then they maintain a full mesh interconnection. But the number of those POP locations is much, much smaller. So for those kind of services, enable SD-WAN to scale better and allow service providers, especially service providers who doesn't own anything, who doesn't own any infrastructure, to provide some kind of managed services. And then we come to the third part. We call it last mile SD-WAN. This SD-WAN becomes valuable for service providers who own and manage their own infrastructures. So network service providers, large ones, tier one service providers, they own infrastructure, or they lease fiber, or they own their own fiber. They build their own provider VPN network, and they provide VPN to their clients, to enterprises with SLA. So everything's good. Many customers, many enterprises use this model to get the basically VPN from service providers. But with the digital economy, digital transformation, making those enterprises needing to put data, push their application to certain locations, maybe the current VPN may not have the last mile to reach those locations. So SD-WAN becomes a very flexible choice, ideal choice to bridge that gap, enable those service providers who own the infrastructure to provide extension to the cloud data center that they don't own last mile. So this last mile can be wireless, can be can be the internet, a third-party ISP internet, or can be Wi-Fi. Different kind of media allow the service provider to provide connectivity to dynamic locations. So with this, you can see that service providers, network service providers, actually can utilize SD-WAN to extend their existing services instead of being feared of SD-WAN, eat their lunch, occupy the provider VPN. Okay, so next, let's go to the poll question.
Great, thanks, Linda. And so now that Linda has given us an overview of a couple different SD-WAN models, we want to ask the audience, which SD-WAN model is your organization most likely to use? Is it going to be the single-tier SD-WAN, hierarchical SD-WAN, or last-mile SD-WAN? And so while we give folks a chance to answer this question, I want to ask Linda if you could talk a little bit about perhaps what some of the concerns are for these different SD-WAN models.
Okay, so yes, one concern is you think about SD-WAN, you utilize internet to interconnect your branch offices. That open up a big security hole, right? So once you have a port facing internet, in the past, your CPE is directly attached to the PE. So it's a physical wire. Nobody can actually tamper that wire. It's harder for people to tamper that wire. Now you have a port facing the internet, and somebody can spoof the target, the source address, and somebody may try to send stuff to you. So first of all is like DDoS. You need a way to mitigate a DDoS attack. Second is you have to recognize who's the legitimate subscribers, be able to accept traffic, especially for the last mile SD-WAN. service providers have to validate who's their legitimate customers or subscribers, being able for their traffic to traverse their Provider VPN.
Okay, thanks for that. Let's take a look and see how we ended up here. Looks like it's relatively equal. The highest at 45% is for hierarchical SD-WAN. Just behind that was the last mile SD-WAN, and only 14% for the single tier. So perhaps maybe what you expected?
Yeah, thank you very much. That's
okay.
Very good. Thank you.
Okay, you're welcome. I'll hand it back over to you then.
Okay. Okay. So that was thanks everybody for entering your result. And here's some of the professional research group study of the single tier versus managed service. And there are studies showing that 30% of enterprises prefer that do-it-yourself service like single tier SD-WAN. The 70% prefer that managed service. Actually, the 30% of do-it-yourself SD-WAN, and that doesn't really only include single tier. It could include multiple tier. This is especially true in Asia. Many of the Asian companies, they actually have their own IT staff to manage their branch interconnection. They lease lines from network service providers and they manage themselves. Like, for example, Huawei does that. We have more than 100 branches across the globe, and we have 2,000 plus people managing the IT services. We have like more than 600 applications, and different applications have to be for the different ways. So we have those hierarchical kind of management service. Not some part of it may not be SD-WAN, but it's definitely hierarchical. So that's from professional research group coming up with the result. And it also shows that enterprise interconnection, the carrier B2B market, is actually growing very fast. And basically, by the estimate by 2020, the SD-WAN enterprise interconnection market will grow 65%. So that's just comparison of the audience feedback with some professional study group coming out. It's quite interesting. So with so much demand for SD-WAN, and especially for network service providers to be able to extend their existing services to those flexible locations, many industry forums like IETF, NEF, ONUG, ONOC, they all have some kind of initiative in this domain. And here I just show one page of the NEF related activities. So NEF has this SD-WAN project. And in this SD-WAN, I just copy and post and cut and paste their specification. One part, very important part, is being able to allow the SD-WAN edge to be able to connect to the MPLS edge and connect the branch offices or cloud data center to the MPLS network through the minimum like third-party internet. So, and also NEF recently started a new project called Cloud Service Architecture. Is to show that for network service providers or for just managed service providers to be able to utilize cloud data center from different providers and provide value-added services, including connectivities, including appropriate service function chaining, including appropriate security services for the enterprise. So the takeaway, the key takeaway from all those industry activities is to say that MPLS VPN is great, and it has provided services for enterprises for 2 decades with security, with SLA. But with the cloud, with digital transformation, they have to be augmented with flexible connection to dynamic locations. And SD-WAN will be an ideal choice to do this flexible extension. So let's look at some of the key components of how do we integrate SD-WAN with Provider VPN. Earlier in the audience show, we have like 40-some percentage of people, audience, thinking this is important for them. Let's look at how actually technically, it's probably drill a little bit too detailed to the technical aspect, but bear with me. If you have questions, you can ask at the end, and can also send me emails to talk about it. So let's start with looking at a typical cloud data center, how they are connected, how an enterprise connect to their workload in cloud data center. So I use AWS as an example. It doesn't have to be AWS. It just simply I personally have used lots of their services, and they have lots of public document available on the internet. So AWS offer VPC, a virtual private cloud, to their clients. And you can have, in each VPC, you can have multiple subnets, and you can even lease virtual router from AWS to interconnect different subnets together. And you can also create your VPC in different availability zones and allow the AWS to interconnect them together for you. And for your enterprise themselves, they provide three types of access. The simplest one is the internet gateway. It's mainly for like you host web information for general audience, and they can use internet to reach those applications directly. No security is enforced. Maybe they will add for the application themselves. They may impose DLS and TLS to have end-to-end security. But from network perspective, there's no security. And then second connectivity to the workload in AWS would be virtual gateway. So for the virtual gateway, is allow you to interconnect your on-prem data center through IPsec, through internet. So that way, doesn't matter where your location is, you can always securely connect your traffic from your on-prem gateway to the AWS virtual gateway. So that's second option. The third option, probably the most secure way, but most expensive way, is direct connect. So basically, you can put your own router into a common place, co-location place with AWS, and lease basically purchase like from Equinix, direct connect to the gateway. With that, you don't have to add another layer of IPsec. So that's just an example of using AWS. Then let's look at some of the issues in using this way. So first of all, for the virtual gateway, if you want to use IPsec connectivity to the virtual gateway, there's a huge limitation. Because of the high computation power required to process IPsec tunnel, there's a limit on, for example, 1 gigabit is constrained for the bandwidth. And also, you have to pay for each connection. So, and also that within your virtual router themselves, the AWS virtual router, it doesn't support L2 multicast. So some of the protocols may be limited. For example, some of the IGPs may be impacted, and some of the like proxy ARP, BFD, all those using layer 2 multicast may be impacted. So this is some of the issues when you use this virtual router within AWS. On top of that is the scalability. So basically, when you have, in this example, you have 4 branch offices, and you need to connect to the virtual workload hosted in the cloud. And to reach them, you have to use the IPsec tunnel for each of the branch office to the workload to the virtual gateway. And you can see that it doesn't scale very well. This is only 4 branch offices connect to workload in 2 cloud data centers. And once your workload increase, very soon that you won't be able to scale very well. For example, not only being expensive, and also the management can be a nightmare. So this, let's look at another option then. So, to reduce the cost, to reduce the connectivity management, if you want to do it yourself, you can create the SD-WAN aggregator, just like our earlier SD-WAN model. You can have hierarchical SD-WAN. Allow your CPE to connect to some POP location as an aggregator and have an aggregated pipe to the cloud data center. So that's one approach enterprise can do. Another approach, suppose this as a service provider, network service provider, you already provide VPN to this particular enterprise. And you probably can put your PE, have a direct connect to some of popular cloud data center, these direct connect, so that you can offer extended services to those enterprises who wish to place the workload in the cloud DC. You can incorporate that into your existing VPN service, make it value-added service, allow those enterprises who already use your VPN, be able to utilize some of the, push some of the workload to the cloud DC without them even needing to managing the connectivity to the cloud DC. So that's the case showing on this PE-8 have a direct connect to the cloud gateway. Another choice could be that some of the cloud data centers, as a network service provider, you don't have or you don't want to purchase direct connect because the demand is now high, because of you're not sure how many of your customers will use this location. And you can create a PE to like a IPsec tunnel, SD-WAN tunnel from your PE to the cloud gateway, so that you can provide similar kind of service to your existing customers, enable them to reach the cloud DC. So you can see from here, as a network service providers, today offer VPN services. You can add more value to your service, provide value-added service to your client. And as we all know from network service providers' perspective, bandwidth is not making much money anymore. The price for bandwidth is dropping. And what enterprises want, not only they want bandwidth, but they also need value-added services. How do they move the data to cloud data center? How do they get diagnostics? How do they get performance information? So those are all the key values enterprise need to transition to the digital economy. So this, you can see that service providers, network service providers, or especially traditional network service providers, don't have to fear the SD-WAN impact. Should utilize SD-WAN to provide new service. Okay, so when we talk about using SD-WAN to provide new service, of course you can depend on the virtual router provided by cloud data centers. Another approach could be you can actually instantiate your virtual router into the third-party cloud data center. And today, like for example, Amazon, Azure, they all have their marketplace. You can purchase your virtual router and instantiate them instead of using Amazon's virtual router. And with this, you can establish your own connectivity to your virtual router, and not only connecting to the cloud data center, but allow the virtual router to interconnect with each other, interconnect with enterprises on-prem data center, so that create your own network and independent of the cloud provider provide to you. So with that, virtual router give you lots of flexibilities. Here are some of the key values virtual router can provide in public cloud. And for one, you can apply like additional security to your client traffic. And for two, maybe you don't need to use their virtual gateway anymore. You can use public cloud internet gateway, just plain vanilla internet access to your workload, but using your virtual router to provide a layer of security. Okay? Another way is being able to put a probe into the cloud data center. So even though many cloud data centers operators give you lots of performance data, but still, it's much better if you see it yourself using your own device. It's almost like a check and balance. And on top of that, cloud data center, they all use private addresses. And when the data coming out of to enterprise on-prem data center, everything has changed. Goes through the net, and address is different. The subnet is different. So having a virtual router instantiate, not only you can bring those additional information, monitoring the performance of your workload and managing the traffic among each other, you can also bring out more metadata. For example, some of the enterprises we work with, they have multiple accounts with maybe hundreds of accounts with one cloud provider. And even for same application, they may have different accounts. So when the traffic comes to their on-prem data center, it's really difficult to tell which traffic is from which account. So if you instantiate this virtual router, you will be able to attach those information. You can attach user-defined information. And so with this kind of virtual routers instantiated in the public cloud, they make it easier for enterprise to expand their work and to be able to see and feel how their workload work in a public cloud, and enable them to be not locking into a single cloud operator. So next one, we come to a poll question. So Ross, I'll pass it to you.
Okay, great. Thanks, Linda. And so now, again, as Linda has gone through a number of different benefits for virtual router, we want to ask the audience which of those virtual router benefits is most useful to your organization. Is it the added security? Is it the ability to probe a cloud data center? Is it to be able to support value-added services? Is it to expand to the hybrid cloud? Or is it to avoid vendor lock-in? And again, we'll give folks a chance, a couple of minutes to answer this. And in the meantime, I want to ask Linda if she can elaborate a little bit more on how virtual routers can actually add security.
Okay. So basically, when you put a virtual router in the public cloud, you can manage the security association between the peers among on your on-prem branch offices, without informing the public cloud operator all those security associations. So the association is completely just between yourself. So that's another layer of security you can add it on.
Great, thanks for that. Okay, let's take a look and see what people said. And it looks that supporting value-added services, about a third of them are saying that. Let's see, 26% said expanding to hybrid cloud, almost 19% added security, and then probing data centers and avoiding vendor lock-in came in relatively low. I would imagine all of these are very important, but it is interesting and probably heartening that it's really about adding value-added services, which is going to be very important, obviously, for the service provider. So that's good to see. So with that, I will hand it back over to Linda.
Thank you. Okay. So so now we come to a little bit details on how virtual router works and how virtual router interconnect with each other. So once you instantiate your virtual router in a public cloud data center, you basically can establish your own security association between your on-prem, either the PE, like for example, if you are a network service provider, you extend your PE to the virtual router in the cloud data center. And then so you can manage the security association between your PE provider edge and the virtual router. Okay, so you can manage that individually. But the problem is you have all those virtual routers, and if they need to communicate with each other without any additional protocols or menu configurations, all the traffic has to be hairpinned back to PE and then sent to another data center, right? So for that reason, for many years in the industry, there's a protocol called ESVPN, Dynamic Smart VPN, or DMVPN, Dynamic Multi-Point VPN. Allow those virtual routers to exchange their information with the PE and then get a security association from the PE and be able to establish IPsec tunnel among themselves. So once the tunnel being established among themselves, they can exchange traffic without sending the data flow like hairpin back to PE. So that DSVPN, DMVPN has been working in the field, even though it's not standardized per se, but has been used. But more and more, we actually find out that there are some scalabilities with DMVPN and DSVPN, primarily because of when those two protocols were first invented, it was only for hub and spoke kind of configuration, assuming there are limited number of spokes in place. And if you want to scale that into a large number of sites, like more than 10, more than 100, there's some limitation on that. So there's some industry momentum in moving, like expanding BGP to achieve that the goal. But right now we're just at on the drawing table and discussing, like in IETF, what kind of thing can be expanded using BGP to achieve that purpose. Because we all know BGP can easily scale up to 20K sessions versus DSVPN or DMVPN, we're talking about 100 or maybe at most, maybe 100 in that range, a big, huge difference. So that's something, if anybody's interested, you can always come to IETF or come to talk to me to point out where the discussion is going to be happening in IETF. Well, the important thing is application-driven forwarding. So in the past, from network providers' perspective, for the network industry, we've been using IFSER, right, priority disk, to indicate how your traffic should be forwarded. From network perspective, you have delay, you have packet loss, and those kind of jitter, those kind of typical performance indicator for the traffic through your network. But when we come to application and coming to the digital economy, the type of characteristics for different applications become much more sophisticated, you should say. Like, for example, because of regulatory reasons, like, for example, in China, they require all data has to be staged in China before they can forward it to another country, right? So if you are a foreign country offering service in China and you want to collect all the performance data, you cannot really collect data directly from your IoT device directly to your country. So the country has their regulations. So make it important that application be able to, like for your CPE device, instantiate in the customer premise, in the edge or in the cloud, be able to recognize the application and dictate how the application can be forwarded. or which data center data this application can access. So it's very important for those CPE devices to carry some kind of metadata to recognize the application and be able to forward differently. And not only the CPE need to be able to select the ingress PE. See, here we are talking about using SD-WAN to interconnect with VPN, right? When you're using SD-WAN to interconnect VPN, that definitely creates a situation of your CPE can actually access multiple provider edge device. And based on the application's needs, and they may choose different PE to ingress to the provider VPN. And on top of that, they may also need to dictate which egress to exit the provider VPN. So all those information can be achieved by the virtual router instantiated in the cloud data center. So here it just shows one example when the cloud data center are very far away from on-prem offices, on-prem data centers. So even though we show that in the hierarchical SD-WAN that you can have POP location, you can have multi-segment SD-WAN, but too many enterprises, they may want to have end-to-end security. They don't want anybody in the middle to mess up their security association. For example, in this E1 to E2 communication, some enterprises prefer they have direct control of the security association. So one of the choice would be they create SD-WAN among E1 and E2 and just let the traffic flow anywhere. They are okay. That kind of model works okay when they are close to each other. When E1 and E2 are physically very close to each other, like say if you are in one city, one campus. But when E1 and E2 are far apart, one in China, one in US, then the traffic can flow anywhere. And if you have a flow consists of 100 packets, 1,000 packets, all those packets can flow in different directions and causing different delay, causing different variations. So performance cannot be guaranteed. So it will be highly desirable to have certain way to control the traffic so that utilize most of the provider VPN. It's almost like you take airplane to a location and then you drive for the last mile. So you want the packet, even though the SD-WAN is not terminated in the provider VPN, but you want a way to steer the traffic as much as possible through the VPN to provide better service, better SLA, and better control. Okay, so now I pass to Ross for another poll question.
Great, thanks, Linda. And so this will be our last poll question of the morning. So now we want to ask, how do you view having an SD-WAN path that maximizes your existing VPN locations? Do you consider this an ideal situation? Is this a useful thing to have? Are you fairly neutral on it, or do you not really care whether or not the SD-WAN path maximizes your VPN connection? And maybe just, Linda, I'll throw it back over to you just to clarify a little bit, and perhaps you can explain a little bit more about why this is an important consideration for people.
Oh, okay. So this is when like two locations are far away from each other, and say if you have just a certain packet, like a very small number of packets, you don't care about delay, that's okay. But if your flow has lots of packets through, and when the locations far apart from each other, then all those packets can be wandering everywhere, can even go through different countries. And like from here, from Dallas to Beijing, some packets can go through Australia, some packets can go to Hong Kong, some packets can go through Tokyo. So create more delay, more discrepancy in all the packets within one flow.
Okay, that makes perfect sense. All right, now let's take a look and see where we ended up here. Okay. Only a few people said they don't care. 72%, almost three-quarters of them say that this is a useful thing to have, and a quarter of them say that this is the ideal situation to maximize your VPN connections. So, yeah, I think that's probably about what we would have expected.
Great.
Okay, I'll hand it back to you to bring us on home.
Okay. So let's look at this. We talked earlier about it desirable to have application driven on how the packet, how the flow is to be forwarded, right? They have different ingress to the provider VPN. Say if you do want to maximize your existing VPN to carry the traffic, even though your VPN doesn't have to terminate IPsec tunnel. So there are many ways to achieve that. And for one thing, if you have a simple way like an E1 to the C1 in this example, to have a simple SD-WAN tunnel, and with that approach, that requires a C1 to be able to recognize applications, which can become difficult because C1 as a provider edge, they terminate traffic from many different clients. So it's almost impossible or very difficult for C1 to recognize all those applications. It's better for E1, like edge device, to recognize the application and adding those metadata on how they can be forwarded through the provider network. And I'm sure lots of people have heard the industry segment routing. If you haven't heard about it, then you can go to IETF. It's a quite hot subject in IETF right now. So segment routing requires lots of changes to the data plane and require the egress node, the source node, being able to determine the entire route through all the segments. So that is definitely useful for our case because from this perspective, for traffic from E1 to E2, even though E1 can make decision on which ingress PE to use, it is difficult for the provider VPN to dictate which egress, how to exit the VPN, because both, for example, in this example, C4 and C6 can reach the destination. The typical network today basically can choose either one to reach to the destination. So using the idea of segment routing allow E1 to encode with some kind of metadata, so that C1, say for example, if the provider network supports some kind of segment routing, and allow the key, the metadata, to be converted to some kind of a binding set so that they can forward it accordingly within the provider network to egress the desired egress node to reach the destination. So we call this source node specified route over hybrid network for SD-WAN, we call SD-WAN++. This one doesn't require every segment, every domain to support segment routing, but achieve the purpose of segment routing. Okay, so this maybe there will be two details on how to achieve that. Basically here we list the two approaches. Actually, more details will be described in the IETF draft. So the ingress node can actually push down the entire segment routing set from the source node, and then the provider edge basically is using those segment routing binding sets to forward accordingly. But this approach requires lots of changes to the CPE node, and also requires quite a lot of coordination between CPE node and provider network. May not be feasible for many service providers who don't want to expose the internal information to external. Another approach is like E1 carry the metadata. This metadata can be in the form of VXLAN ID, VNID, or can be GRE, the key, to represent the metadata of the application. Then the provider VPN can use this metadata and map into appropriate property to forward within the provider network. So next one is for this kind of segment routing or domain routing per se, and yes, also have a use case on this. This is really about when you have two end devices, SD-WAN. This SD-WAN path need to be steered through multiple ISPs. And how do we achieve that? We can use similar approach to achieve that goal through multiple service providers. And that concludes my presentation. And for the last 3 slides, maybe a little bit too technical and too much detail, nitty-gritty detail. And we have some IETF internet drafts describe more details if you're interested. And so thank you very much. And now I pass to Ross for some additional questions.
Great. Thanks, Linda. And thanks, everybody, for sending in some questions. Let's take a look and see what we've got. Okay, first question here. The poll results from the first polling question showed some interest in the last mile SD-WAN. And so someone's asking, would it be possible to elaborate some good, bad, and ugly things about last mile SD-WAN?
Okay, so good and bad. The good thing is network service providers today can use SD-WAN to extend to new locations, to the locations where they don't have physical connectivities, and especially useful for the cloud access. Though the ugly thing is today's VPN, Provider VPN, the PE is normally directly connected to the CPE. So they don't have to worry about the traffic coming in. All the traffic coming in are legitimate. But once you open the door to internet, SD-WAN, then your PE becomes, you have to receive traffic from everybody. Then they could have a DDoS attack. They could have malicious users try to spoof the legitimate subscribers, putting traffic free of charge through your provider network. And so there could be many of those issues happening. And in the IETF draft, we talk about different mitigation methods to address those issues. So for people interested in that question, definitely please have a look in those drafts.
Okay, thank you. Next question. Is there any way to steer an SD-WAN path through a provider VPN without segment routing?
Yes, you can. If the traffic, you only need to choose the ingress PE, then the source node can choose ingress PE very easily. It's just the egress, how you exit the provider VPN. So segment routing is a very easy way to provide that option. If you don't use segment routing, you can use menu configuration or use some kind of additional configuration in your PE device. Depending on different key, you can use different exit address to exit, just another layer of configuration.
Okay, thank you. Let's see, another question. Would it be possible to elaborate on some of the implications or complexities with SD-WAN in the post-GDPR era? Kind of getting back to some of the security stuff we were talking about.
This one, can you repeat the question again?
Yes, they're asking if you can talk about some of the implications or the complexities that come from GDPR as relates to SD-WAN. And that's kind of a big question.
This is the group policy, is that correct?
Yeah, this is the security, the new security policies in the EU.
Yeah, that's right. That's right. Like a general data protection kind of regulation.
Yes. Yeah.
Right. So actually, this is a very important aspect. That's why this becomes very important for adding another reason why we need a virtual router there to be able to recognize your application, recognize what data can be stored where, and be able to forward traffic accordingly. Like, for example, same application, if the application is used in one country and they can only access data from this location. If this application running in different countries, then they have to use data from different locations. So that basically gives more, adding more requirement on the virtual router to provide those kind of guidance. to comply with the policies, regulation of the local government.
Okay, thanks for that. So we've got a few minutes left. Got to answer a few more of these. Here's an interesting one. Which type of SD-WAN service makes the most sense for a smaller operator to offer? And the person also asks, what should we be doing now to prepare for SD-WAN? Do you have any suggested steps?
For the smaller operator, I think it should be a combination of hierarchical SD-WAN supplemented by last mile SD-WAN. For a smaller provider, right, you must own some infrastructure. So for certain locations you don't have access to, you can use your infrastructure PE to reach those locations using SD-WAN. But maybe if you want to expand your new services in a completely new environment, because of you have those backing on managed service, you can use the over-the-top. So this experience are very important, not just like a Joe Blow who just coming up, buy a bunch of devices and provide service. And with a smaller provider, if you have the experience of providing managed service, providing diagnostic tools, providing reporting services, definitely can use those hybrid SD-WAN with the last mile together.
Okay, thank you. Let's see. We've got another security one. Isn't it a security concern since a provider VPN could receive traffic from the internet?
It is. Provider VPN, if you offer last mile SD-WAN, then you have to accept traffic from internet. And you can use a similar approach as your cell phone, right? When you call somebody, you have to be verified with your identity and then validate legitimate subscriber before your call can go through. Similar approach, maybe not full scale, those kind of approach can be applied to the provider VPN edge to validate subscribers. Of course, security is always a balance. You can put lots of security there to guarantee none of the invalid traffic can go through your network. But you have to compare the cost, whether you want to spend $10 to prevent them or you want let them to go through your network, which only costs you $5, right? So it's a balance of the network service providers, how much security you want to apply and how much you can tolerate third party traverse your network free of charge. So it's a balance.
Okay, great. I'm going to make sure I push out the survey before we run out of time here. We got about a minute left. Let's see. Okay, here's one. To realize SD-WAN over hybrid network, that means with overlay and underlay, how many controllers or types of controllers would be required?
So you need minimum 2. One is your SD-WAN controller, so control the edge devices. And one is the one control the underlay device, underlay network. So you need some kind of interaction between those two controllers. At least you're saying, okay, between my edge E1 to E2, I have 3 properties. And property 1 has to go through traverse particular location. Property 2 has to be no packet loss. Property 3 can be anything, a best effort. And then the underlay controller has to be able to provide that connection for you. So you need at least 2. And when the network gets bigger, then you will have probably hierarchical controller. You may have local controller. Like for example, in the hierarchical SD-WAN case, maybe you will need lots of local controllers to control the local CPEs. And then the local controllers can talk to each other. I answered the question.
Okay, great. Thanks very much. And it looks like we are at the top of the hour, so we're going to go ahead and end it for now. So thanks, Linda, for all that. That was a lot of information there, and I hope people can find it all very useful. And thanks everybody for dialing in, and we hope to see you on another Light Reading webinar soon. Have a good day, everybody.
Okay, thank you. Bye.